In this video, we're going to introduce you to some features of Stata that you would use when you get a new data set and you're trying to understand what the data set contains. We're going to look at different commands like how to change the directory, change your default directory, how to show what's in that directory, how to read a Stata data set into Stata, how to describe the data, summarize it, list out, edit, and browse the cases, and create a codebook. Let's go ahead and look at Stata now. I have Stata up and running, and I've got my basic windows. We've looked at these in another video, but let's look at them one more time. I have my review window on the left, and anytime I enter a command or run Stata commands from a do file, those commands will show up in that review window. They can be copied and put into other files and saved for later use, or they can be reused right out of the review window. The biggest window is the results window, and you can see that it has the Stata copyright information and some opening notes when the system began to run. This window is the only window that doesn't have a name attached to it. So the review window tells you it's the review window, but to save space, the results window is totally open. Going clockwise, we have a variables window. Tell us when we load a data set what's up with our variables. A properties window down near the bottom, which will give us detailed information on individual variables in the data set. And our command window at the bottom, where mostly where I'm going to work today is by entering commands by typing them in. If I make mistakes, we'll get errors, and we'll have to fix them later. Up at the top, we have a menuing system as well. So let's go ahead and look at our first command. When I start Stata, my default directory on my computer is c:\users\a_new_documents. Stata started using this documents folder on a standard installation as the default folder. I'm going to change my directory now to my desktop. So I'm going to come down into the command window. I'll just come down here and click, and I'll enter my command. The command to change directories is cd, and now I type in my directory, c:\users\a_new_desktop. Now I get an error here that it's unable to change to that directory because I must have misspelled something or left something out of that command. You can see in the results window that errors show up as red. Depending upon how you have your preferences set, errors could be different colors, but the default error color is red. I want to reissue this command and then edit it. I can see I've made a mistake in my directory. So I'll come up here to the review window, and I'm going to single click on the bad command, and that replays it into my command window. And now I can come down and edit out that extra E and use the enter key. Now when I look in the results window, you can see that it shows the command that I issued, and the result is to echo that command back to me. And I can verify that I've changed directories by looking down at the bottom left corner and seeing that the default directory has changed from my documents folder to my desktop. On my desktop, I have a Stata file that I've created before. It's a subset of the General Social Survey. I want to see if the data set's there, and I'm going to do this by typing in the dir command for directory. And again, looking in my window, my results window, I see that there's a data set called SOCY699C-GSS-subset.dta. Files that end in .dta are typically Stata files. If they're created in Stata, then they should have that .dta extension. I'm going to use this file, which is the Stata command, use, to bring it into Stata. So back to my command window, use, and now I just need to type the dataset name. Notice here I've left off the .dta. With the use command, Stata assumes that you're going to be using a Stata file, and it knows that the extension is .dta. Again, my results window, it shows me the command that I issued, and then it has a response, which in this case in parentheses it just tells me the date that this file was created. Now when we look around the screen, we can see that we have some new information available to us. In the variables window, over in the upper right, we have our variable and labels. So here I'm highlighting the year variable, and we see that the variable name is, or the mnemonic is YEAR. We see that it says the label is the GSS year for this respondent. Coming down to the bottom, I just clicked on income 1000, and this is the respondent income in constant dollars in thousands of dollars. And at the bottom in the properties, you can see that I've got some additional information down here. It tells me that it's floating point, how it's formatted, that there's a note attached to it. When I created this variable, I created a note that had the command that created it. And I can look at my file names for the whole data set, when it was created, and that there's a note on the data set, which is this is a GSS subset for Stata demonstrations. So we've been able to change directories, look at the files in that directory, or the Stata files in that directory, and now use them. All right, let's move on to some new commands. Once we have a data set loaded into Stata, we'd like to be able to understand what the data are made of, what they're made up. We have to have an understanding of the contents of the data set. So there's a command called describe. Before we go to describe, I want to take you to the help file, because you're going to spend a lot of time when you don't understand a command pawing through the help files to try to figure out what's going on. From the command window, so I'll just come down here and click in the command window, I'll type in the Stata command help, followed by the command that I'm interested in, which in this case is describe. This brings up a Stata window. This is called a Stata viewer. All files in Stata can be seen in this viewer window. This is when I do help and a command name, it takes me to a text file, which is a help file with all the commands in Stata and all the help available. There is more extensive documentation available to you in Stata in PDF files, and we're going to look at that in a minute. When you look at this help file, what you typically get is the title up at the top, the syntax, a list of all the options, and that's at the top of every help file. When you move down a little lower, we have a description of the particular command. I'm going to scroll a little bit. A detailed description of the options, any comments under remarks, and then the part that I think is most useful all the way at the bottom are the examples. And I say the most useful because typically when I need to do something, if I go right to the examples, I can often find an example of exactly what I want or something very close, and it saves a lot of time trying to read through all the options and all the command issues. That doesn't mean I should never go back and learn those things, but sometimes I'm just in a hurry and I go right to the examples and I can figure out what I need to know. I'm going to go to the top of this help file and show you that these blue highlighted areas, which again, depending upon your installation, may be a different color, these are hyperlinks. This particular hyperlink up here on the top where it says describe will take me to the PDF documentation for this command. I'm going to go ahead and click on that and show that to you. Here's the PDF documentation for the describe command. The PDF files are PDF files of all the Stata documentation, and we're talking about hundreds and hundreds and hundreds of pages. It's the complete help manual for Stata. This used to be sold separately in books and would cost, and I think it used to cost, hundreds of dollars, $300-400, and now they include this as part of the cost of your Stata license or your purchase of Stata with every installation of Stata. I spend a lot of time with the PDF files. It's more detailed than the online help files, which are text files. Let's go ahead and look at this particular command. I'm going to zoom in a little bit. In particular, look at the syntax. To be able to use the help files well, you really need to understand the Stata syntax. So under Stata syntax, I've got the command describe, D-E-S-C-R-I-B-E. Notice that the first letter, D, is underlined. So describe is the command, and it can be abbreviated to the part that's underlined. For this particular command, it can be abbreviated to a single letter. So I could type D, D-E-S, D-E-S-C, or describe, but I have to type at least the letter D to use the describe command. I wish I could have learned that shortcut earlier, because I always type DESC kind of by default. It just makes sense to me, and I learned and I did that early, but D would obviously be a bit more efficient. After the command, you start seeing other things that are optional or options, and there is a difference between being optional and being an option. Once you understand this distinction, reading Stata documentation is a lot easier. First of all, any command or any part of a command or any option enclosed in square brackets, here for example varlist or comma memory underscore options, are themselves optional. So I'm looking at this command and it says describe, varlist is optional, comma memory options is optional, and I know that at a minimum I have to enter the letter D and then the enter key. On the other hand, a var list or variable list is an option. If I don't want to describe all of the data in my data set, all of the variables, but just specific variables, I can enter them as a variable list, but I'm not required to do that. Well, why would this be a good option for us, or a good optional part of our command? Well, in the General Social Survey, there are over 5,000 variables available to us. If we just type D or describe, it will attempt to provide a listing of all those variables, and it's probably too much, way more than we wanted, when in fact I might only be interested in a small number of variables, and I could just list them here. Okay, I said that there are things that are optional, and then there are options, and to make this more confusing, the options are often optional. So how do we know what an option is with a command? Anything that has a comma and then something after it, the thing after it is options. So here I have memory options. That is an option to the command describe, memory options. Itself is optional. My option in this case is optional. So this sounds kind of tautological and crazy, but as long as you remember that the thing that separates the command from its options is a comma, in this case describe is the command, memory options are the options. How do I know that? The comma separates the two. Then I can keep this clear in my head. One more complication you'll see with some of the other commands, options can have options. And when you have options with options, how do we know what the sub-options are? Again, they're separated by commas. Let's go ahead and just enter D. Well, I'm going to type in describe this time. We'll enter describe and see what kind of output we get. In my results window, since I used the command D and I didn't specify the optional varlist and I didn't specify any options, it provides me all of the information for every variable in my data set. And you can see I don't have too many variables here, so that was an okay thing to do. Here's the information we get. We get the variable name or mnemonic. That's how you always refer to the variable in the Stata data set. We get the storage type of the variable. You can see that most of the storage types here are byte, and then we have a couple of integers, 2 floating point variables, and a double precision variable. Mostly you don't need to worry about this, particularly with small data sets, but the basic issue here is that numbers require different amounts of storage space to be able to be stored in your computer. And some kinds of measurements require more space. The most inefficient storage, but for data that contain the most precision, numerical precision, are the double precision variables. Most of these variables are stored as bytes, meaning that they range, that they're very small numbers and integer numbers. We'll show you later on how to look up in the Stata help file to see the different kind of storage types. Mostly, at least for the time being, you're not going to have to worry about this. The next column shows us our display format. Well, numbers are stored in Stata as the number they are, but they can be displayed differently. For example, the number 1000 could be displayed as 1000, or it could be displayed as 1,000, or it could be displayed as 1,000 decimal point 0. It doesn't change the number that's stored in Stata, it only changes how it's displayed on the screen. If you've used spreadsheets, you understand that there are numbers stored in cells, and then you can change the way that those numbers are displayed on the screen. That's what the display format tells you. And again, we'll teach you how to understand that display format later. The next column is value labels. A lot of data sets don't have value labels, but we know that the computer or Stata will store most of our variables as numbers. For example, gender will be stored as, in the general social survey, as 1 equals men, 2 equals women. And that's not that useful. So what we'd really like is to be able to see on the screen men and women, or male and female. That's what the value labels do. They map a number stored in Stata to a label, so when we display data, we see the label and not the number. The number's still there, and the number is how Stata thinks of the variable, but the value label is how we think of it. And so you can see some of these value labels are very clear. Marital, child's, age, sex, those make some sense. Some of the others are just LABBP, LABCC, and they're a little bit less sensible. But we could go look at the labels or look at the underlying data, and we can figure out what they mean. Finally, we get a variable label. Again, not all data sets will have the variable label. I encourage you, when you're working with your data, to work very hard to use good variable names and good value labels and good variable labels. So when you share your data with somebody else or you're working with your data, you have a better understanding. So the variable labels simply tell us a little bit about the content of the particular variable. We can see that I have a variable called sex, which is a byte variable, and it has a value label, and the variable label is respondent's sex. Right underneath it, there's another variable called sexchar, SEXCHAR. You can tell from the storage type that it's a string, it's not a number. And you can see that the variable label is respondent sex, and then I have in parentheses string. There's no numerical information in that variable. So going to describe, we learn quite a bit. We get a little more information when we look at the top. We can see that there are 57,061 observations, 22 variables, and the size of my data set's about 2.4 megabytes. We can see when it was created and that there are notes attached to it. Notes is something that we'll talk about a little bit later, but you can, when you're working through your data, you can add notes to your data set to remind you of things or to let others know what you've done. That's the describe command. But now we want to start looking at the numerical information in the data. And what I'd like to do is use something that would give me a numerical summary of all the data. One command that can do that is the summarize command. I've entered summarize down in the command window. My suggestion to you is the minute you learn about a new command like summarize, that the first thing you do is type in help summarize. And again, you'll be taken to the text file, and you'll immediately see the syntax, and we can see that we can enter the command SU, which is the minimum amount Stata needs to determine that we mean summarize, and that's all we need to do. We have an optional varlist, an optional if, an optional in, an optional wait, and then we have options which are themselves optional. But all we have to do is enter SU, and we'll get some output. What do we get with summarize? Well, on the far left we get our variable name, our mnemonic. We get the number of observations, the mean, the standard deviation, the minimum, and the maximum. And we can tell a lot from this particular output. We had all those variables listed as bytes, and we can see now that most of them are variables that have a range starting at 0 and going to about 20, but really typically between 1 and 4, 1 and 7, that kind of thing. We can see that the variable sexchar, SEXCHAR, has 0 observations. Well, that's a little misleading. There's observations there, but summarize gives us a statistical snapshot of the data, and Stata does not do statistics on string variables or character variables. It only works on numeric variables. We can also tell, looking at some of the averages, how big these numbers are. For example, CONR Inc., which stands for constant dollars respondent income. We have 33,365 respondents, and the average income was $31,770.02. So we get a sense of the magnitude of the variable. I told you that I created a variable called income 1000, and we can see it below and see that it is simply CONR Inc. divided by 1000. That is, all the numbers are identical except for the decimal place. So summarize provides us a very nice set of information. Both describe and summarize allow varlists. So let's go ahead and show you what that looks like. If I type in D for describe, and I type in my income variable, and enter, it provides all the information contained in describe, but this time just for the two variables. Similarly, if I enter summarize, or my abbreviation of summarize, for these variables, it provides all the summary statistical information, but just for those two variables. So the var list, which is optional in many commands, can be quite important at limiting the amount of information provided. Well, let's look at another command. This command is called list. The list command can be dangerous. For example, if I type in list with no options, Stata is running through my data set. It's producing all this output. We're up to about 20,000 cases. I know there's over 50,000 cases, so this is going to take a minute. How do I get out of this? Control break or the red X at the top of the window, but we'll just let this run. And this produces virtually no useful information. So this is an example where if I just want to list out my data, it might be useful to use some of those limiting features and look at just one or two variables. For example, I can type in list. Let's type in year as one variable, income. I'm sorry, I would do these in order that I did before. And you can see that this is a much smaller output. Now, there's still about 57,000 lines of data here, and so it's too much for me to comprehend. I may want to limit this more, but even after doing that, it's literally showing the numbers stored in Stata. One thing we can see here, and we're not going to go into great detail, is that not every case has a number. Let's look at the last case, 57,061. The data are from year 2012, and you can see that the value for the two variables are period I and period. Anytime you see a period in Stata, it's missing values. This particular respondent either decided not to provide their income, or provided an income that just didn't make sense, or were not asked to provide their income. The respondent above them, case number 57,060, provided the income response and said that their income was $14,362.50. Anytime we see period in a letter or simply a period, missing data. So list can be useful to begin looking at our data, and I'm going to encourage you to limit the number of variables, and later on we'll show you how to use the if and in modifiers to again make your listings a little more sensible for you. I'm still trying to get a handle on the data that I have here, so it would be nice if I could look at my data in a spreadsheet-like environment. There's two commands to do this. I'm going to show you one of them called browse. This is the command that I think is the better command, because you can't ruin your data. You can't make any changes to the data. If we use the edit command, you can make changes to your data, but they're not going to be documented and they could be accidental. Again, how would you find out how to use browse in great detail? Help browse. But if I type in browse with no options, it opens up a spreadsheet. Down the side I have a listing of my observation numbers, 1, and it starts at 1, and we'll go to the number of observations you have, in this case well over 50,000. I have the variables listed across the top, and it looks just like a spreadsheet if you've ever used Microsoft Excel or Google Docs. You'll notice that there are different colors in this spreadsheet. When the color of the variable, the value of the variable is black, it tells us that it's a pure number. When it's blue, it tells us it's a number with a value label. And when it's red, it tells us that it's a string. So let's go ahead and move over here to the sex variable for the first person. You can see that this person is female. That's the value label. But when I look up into the little spreadsheet bar up here, it shows that that person is coded 2. So now I've learned that women are coded 2. What about men? If I come down one cell and I highlight person number 2, who happens to be a male, and I can tell that because it's Stata is showing me the value label. But up here, in where I see the actual value, it shows me that it's 1. So the variable sex is a numeric variable that has the values of 1 and 2. And while I don't see any here, I suspect there may be some missing values, and they would be represented with a period or a period and a letter. Let's go over to the sex care variable and just click on the first person. I created this variable just to show you how it shows up in this browse window. Notice that it says female, and so sex and sex care, when we look at them in Stata, appear identical, but in fact one is numeric and one is string. And looking up at the little box up here, we can see there's no numbers there. This is actually containing a string variable. Stata is not good at using string variables in the sense that you can't do any statistical analysis of them. You can't use them in most analyses. The data need to be stored as quantitative or numbers, even if you attach labels to them. And again, I encourage you to do that so they're easier to read. We can just scroll through our data. Let's look at another one. Well, let's look at race. Case number 8 is the respondent was white, and they have a value of 1. And coming down here to case number 9, I can see that they're black and they have a value of 2. And so again, I've learned a little more about this particular variable, that my race variable has at least 2 values. 1 equals white, 2 equals black. You can't make any changes in here. I can't change if I had miscoded this person, if I was entering these data and person number 9 was actually white, I can't change them here. I could do it in the edit window, which looks identical to this, but I believe that's a bad method, because once you make that change, you don't have any evidence that you've made the change. And you need to be able to, kind of like a forensic accountant, be able to show all of your changes over time. When we get into the actual programming part of Stata, I'm going to show you a method for making those kinds of changes and documenting them and knowing that they're as correct as they can be. The last thing we're going to look at here is a command called codebook. Codebook also takes the argument of variables, a var list. So let's just do codebook, and let's just look at a few variables like marital and income. This is something you might want to do at the beginning of a Stata session when you get your data set, unless it has too many variables, and just produce a large codebook that you could store on your computer's hard drive, and then use an editor to go through and search for things when you need to know more information about particular variables. Of course, since codebook takes the var list as part of its command, you can always just do this on the fly. So here I find out that my marital variable is numeric, and it's stored as a byte. It has a label called marital, and it ranges from 1 to 5. Now when I look down at the tabulation, I get, in essence, a frequency distribution, and it shows me the label married, widowed, divorced, separated, and never married, the associated numeric values 1 through 5, and then the frequencies in my data set of those things. Moving down to CONR Inc., so our income variable, respondent's income in constant dollars, you can see this is a numeric variable stored in double precision, has a label, which we'd like to know a little bit more about that label, and it gives us some examples of values down below, like 16,864 and 36,135. If I type in codebook with nothing else, it goes through every variable in my data set, and I only have 20 some odd variables here, so this was very quick and easy. With thousands of variables, this is going to be a real problem, and you probably don't want to do it, but it would be nice if there was a way to capture this output and save it to a file so you could look at it later. There is, and that's something we'll address in a different video. So let's quickly review the different commands that we've looked at. We reviewed all the different windows in Stata. We looked at the cd command to change directory, the dir command to show us the Stata files in your directory, the use command to read a Stata data set, describe to show us information about the whole data set and about all the variables, summarize, which gives us a numerical snapshot of all the numeric variables, list, a way of listing out all of our data, edit and browse, and finally codebook. Again, your friend in Stata is the help file. With these commands, my advice to you is to take each one of them and type in help and that command and go through that codebook, go through that help file until you understand how to use that variable. If you have any questions, please feel free to contact me and I'll do my best to answer them.